In this video we will also go over electron configurations, but the main difference is we're going to go over the electron configuration of ions. So remember, if you are a cation, a plus charge, that means you release or sacrifice an electron. If you're a minus charge, we call that an anion, and if you become a minus charge, or to become a minus charge anion, you have to gain electrons. So having a -1 means you gain 1 electron, having a -3 means you gain 3 electrons, so on and so forth. So the first question, part A, is lithium plus. So looking up lithium plus in the periodic table, here's lithium right here. Okay, it's hard to see because it's marked over. Lithium is atomic number 3 in the periodic table. That has 3 electrons. However, lithium plus would mean that it loses an electron. It would have 2 electrons now, because to gain the +1 status, it loses an electron. Remember, pluses mean you lose electrons. So the electron configuration of lithium plus is going to be the same as helium, and the electron configuration of helium is 1s2. So if we want to write the ground state, that's just writing everything out without using the nearest noble gas. And so for lithium plus, that's going to be 1s2, which is actually the same thing as the electron configuration of helium. So actually lithium plus as an ion and helium as a neutral element have the same electron configuration. We call that term isoelectric. H minus, so looking at H minus in the periodic table, that's 1 electron, 1s1. To become H minus, it gains an electron. So yes, it becomes like helium. It has the electron configuration of 1s2. So H minus, it turns out, will have the same electron configuration as helium, 1s2, which also is the same electron configuration as H minus. So again, we have here an isoelectric series between H minus, Li plus, and the nearest noble gas of helium. The next problem on this list is N minus 3. So that is nitrogen that has gained 3 electrons. So let's look at our periodic table here. Right, nitrogen gaining 3 electrons means neutral nitrogen has 7, and gaining 3 would make it its nearest noble gas of 10. So the electron configuration of nitrogen, N minus 3 that is the same as neon. What is the electron configuration of neon? We can go back. The electrons march in a specific order. It's going to be 1s2, 2s2, and then 2p6. That is the full electron configuration of neon. Right, looking at F minus, which is the next part of this problem, F minus, 9 electrons is normal neutral F. It gains 1 electron to become F minus, so it's going to be 10 electrons, the same electron configuration as neon. So again, we have what's called isoelectric. F minus, or the fluoride ion, is the same electron configuration as neon. So here we have 3 elements, 2 of them ions, N minus 3 and F minus, and the noble gas neon, that have the same electron configuration. Another example of what's known as the isoelectric series. S minus 2 is the next one in the problem list. S minus 2 is actually neon 3s2, 3p1, 3p2, 3p3, 3p4. S minus 2 gains 2 electrons. It becomes the nearest noble gas of argon. So what is argon in the ground state? Argon in the ground state is neon 3s2, 3p6, right? S minus 2 would be argon. Now it's asking you for the ground state, so we'll put everything out. It's going to be 1s2, 2s2, 2p6, and then 3s2, 3p6. Okay. Obviously, if you remembered, 1s2, 2s2, 2p6 is just the same thing as neon, but it's asking in the problem the ground state. So the ground state, you have to write everything all out. So Al plus 3, looking at Al in the periodic table, plus 3 means it lost 3 electrons. So another isoelectric series with neon. So the nearest noble gas of Al plus 3 is going to be neon, and the electron configuration of neon is 1s2, 2s2, 2p6. And again, more isoelectric elements, N minus 3, F minus, and Al plus 3 have all the same electron configurations as neon. Se minus 2, this is selenium. Selenium is here in the periodic table. Minus 2 gives it Krypton. So here we're going to write the electron configuration of Krypton. And it's actually argon 4s2, 3d10, 4p6. So that's how the electrons are going to go. As you know, argon has the electron configuration of all of this. I'm not going to write it all out just to save some time and some space, but this is argon, and then you attach it to this, and you have the full ground state electron configuration of Se minus 2. Br minus, halogens usually like to be minus 1 in the periodic table, so this is going to be Krypton. So Br minus will have the same ground state electron configuration of Krypton, which we know is this. Isoelectric series between Br minus, the electron configuration of Krypton, and selenium minus 2 all have the same electron configuration. Same thing with Rb plus. So rubidium plus is 5s by itself. Rubidium plus 1, when we remove that electron in order to be plus 1, it loses that electron. 37 electrons become 36, and then we have another similar identical electron configuration with that of Krypton. Sr plus 2. Sr plus 2 is in group 2 of the periodic table, or 2a. These are the alkaline earth metals. Sr plus 2, as all ions in group 2a like to be plus 2, and here we see it having the same electron configuration as Krypton. So Rb plus, Sr plus, its nearest noble gas is Krypton. Br minus, Se minus 2, its nearest noble gas is also Krypton. Sn plus 2, Sn is the element tin. So tin is right here in the periodic table. We're losing 2 electrons. So we lose one, we lose the other, and now we become the same electron configuration as cadmium. The electron configuration of cadmium is going to be 36 electrons of Krypton, 36 electrons of Krypton, and then we're going to fill up 5s2, and then 4d1, 4d2, 43, 44, 45, 46, 47, 48, 49, and 4d10. So the next one on our list is Te minus 2. So Te minus 2 is right here, beryllium in the periodic table. Minus 2 means it will have the same electron configuration of xenon. So beryllium minus 2 will have the same electron configuration as xenon. Ba plus barium plus 2 will have the same electron configuration as xenon. So Ba plus 2, here's Ba in the periodic table. It loses 2 electrons. Its nearest noble gas is xenon. Xenon, beryllium minus 2, and barium plus 2 are what are considered isoelectric. Lead plus 2, so looking at lead in the periodic table. Lead is right here, atomic number 82, 82 electrons. Lead plus 2 will be 80 electrons, so it will have the same electron configuration of mercury. And mercury is going to be xenon. 6s2, we go to the 4f14, and then from the 4f14, 5d10, and 5d10 will be right here at mercury. So that would be Pb plus 2. You lose 1, you lose 2, Pb plus 2 will have the same electron configuration as mercury. In plus 3, so the electron configuration of indium plus 3 as an ion is going to have the same electron configuration as palladium. And palladium has the electron configuration of Krypton. So indium plus 3 will have the same electron configuration of palladium. So that's going to be Krypton, 5s2, 4d, here's palladium, 4d1, 4d2, 43, 44, 45, 46, 47, and then 48. So indium plus 3 will have the same electron configuration of palladium, which is Krypton, 5s2, 4d8. Thallium plus 1, so here's thallium, plus 1 will have it the same electron configuration as mercury, and mercury is going to be xenon, 6s2, then we go to the 4f's, then we fill up the 5d all the way to 5d10. So thallium plus 1 is going to be xenon, 6s2, don't forget the 4f's now. We have to fill up the 4f's. Then we fill up the 5d's. The order matters on how the electrons go marching in. And finally we have thallium plus 3. Well, here's thallium once again. Plus 1 is mercury. Plus 3 will mean the 81 electrons get reduced to 78 electrons. So here we're talking about the electron configuration for platinum. So what's the electron configuration of platinum? It's going to be xenon 6s2. Then after 6s2, the electrons will fill 4f. Then go back to 5d, and then it's going to be 5d1, 5d2, 5d3, 5d4, 5d5, 5d6, 5d7, 5d8. So it's going to be xenon 6s2, 4f14, 5d8.